Okay. Hello everyone. I hope you all started a great Monday. Before getting started, do you have any questions from the previous session? We discussed about resistors. Raise your hand if you have any questions. Okay, sounds good. We discussed about resistors and we said it's an electronic component that limits the current in a circuit. And today we want to learn how resistors work when we connect them in series and in parallel. So here is what we are going to learn today. Number one, what is the difference between resistors in series and resistors in parallel? Number two, how to calculate the equivalent resistance for both series and parallel connections. And number three, how to build series and parallel resistor connections on a breadboard. Before we start, let's talk about why we need to connect resistors in series or in parallel. Here are two scenarios in which we need to think about combining resistors in series and parallel. If you look at a resistor kit from Amazon, you see the resistors come in strange values like 4.7 or 47 ohms, not simple numbers like 5 or 50. Sometimes when we build a circuit, when we design a circuit, we need a specific value for the resistor and it's not available to buy. So we have to combine resistors in series and in parallel to create the new value we need. Also, simply sometimes we don't want to buy new resistors and we want to use what we already have. So we use them to create the new value we need, okay? So let's look at resistors in series first. When we put three resistors in series, for example, R1, R2, and R3, the resistors are connected one after another. It means the end of one resistor, for example, the end of R1 is connected to the beginning of another resistor, the beginning of R2. Then the resistors just add to create an equivalent resistors that is larger than the individual resistance of each resistor. It means R equivalent equals to R1 plus R2 plus R3. Resistors in parallel are a little trickier. If I put three resistors in parallel, meaning both ends of the resistor are connected, the equation that gives me the equivalent resistance is 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3. Or in other words, the resistance add inversely. And the equivalent resistance is less than each individual resistance value. Let's see how the holes on a breadboard are connected. Two pictures at the top show power rails. All holes in the same blue line are connected and all holes in the same red line are connected. Two pictures at the bottom show holes are connected vertically in groups of 5. So if you place two parts in the same vertical group, they are connected. And that is how we use breadboard to build series and parallel resistor connections. Here we can see how to connect resistors in series and parallel on a breadboard. On the top part, the resistors are connected one after another. As I said, the end of the first resistor is connected to the beginning of another resistor. That is a series connection. And on the bottom, the resistors are connected side by side. Both sides of the resistors are connected to each other, which is a parallel connection. Here we have three resistors, R1, R2, and R3, all in 10 ohms, and three of them are connected in series. As we said in series connection, the equivalent resistance is the summation of all resistors, resistor values, which is 30 ohms, and 30 ohms is larger than each individual resistance, which is 10 ohms. And on the left side, you can see the real setup, and I used a multimeter to measure the equivalent resistance. The multimeter shows 30 ohms, which is aligned with what we calculated theoretically. Now here we have an example of resistors in parallel, 3 resistors, each 10 ohms, connected side by side in parallel. As we said, the resistor values are added inversely to calculate the equivalent resistance. It is less than each resistance. And on the left side, you can see the real setup, and I used a multimeter to measure the equivalent resistance, which is 3.4 ohms, less than each individual resistance, which is 10 ohms. Okay, now let's quickly review what we have learned today. In series connection, resistors are connected one after another, and the equivalent resistance is the summation of all the resistor values, and it increases when we add more resistors. However, in parallel connection, resistors are connected side by side, and the equivalent resistance is calculated by adding the reciprocals of the resistor values, and it decreases when we add more resistors. Now, as Halloween is coming up, we want to light up our class with orange LEDs, but we only have a few resistors. Your mission is finding the right combination for the resistors to get about 350 ohms total resistance so that our LEDs do not burn out. Available values are 100, 150, 220, 330, 470, and 680 ohms, and we don't want to buy new resistors. Let's see which group can find the best resistor combination first. Please work together and tell me your result when you are ready.